Okay, this video is just a quick video to review a few problems for your tests coming up this week. So on the first one, we need to sketch a graph. But to do that, we need to figure out the end behavior and we need to figure out the zeros. So to figure out the end behavior, if you remember, we have to look at the degree and we have to look at the leading coefficient. So on the first one, if I'm counting the degree, we've got 1x, 2, 3, and then 4. So my degree is 4, which is even. My leading coefficient is -2, which is obviously negative. When it's even, we know they're going to go the same ways. And when it's negative, that same way is down. My zeros are what make the parentheses 0. So I have one at -5, one at +2, and what makes x a 0 is just 0. So I'm going to make my points here. We know that we're going to end down on both sides. And as we're looking through it, the 2 occurs twice. So when it occurs in even time, it's going to bounce. But on these, they just occur once. So it's going to go through. So as I sketch my graph, we're going to go through, bounce, and we're done. Okay, on the second one, if I'm looking at determining the end behavior, I first have to figure out the degree. So for my degree, I have 2, 3, plus another 3, which is 6. My leading coefficient is an invisible 1. So we've got even and we have positive. Okay, if it's even, it's going to go the same way, and positive, that same way is up. What we don't have on here, and I'll just tell you now, if it is an odd degree, then they're going to go opposite ways. And if it's odd and positive, we're going to go up to the right and down to the left, just like a line would. And if it's odd and negative, we're going to go down to the right and up like a left, just like a line with a negative slope would have. Okay, so now if I'm graphing this, I got to figure out my zeros. To make the x squared 0 would just be 0. To make the x plus 3 0 be -3. To make the other one 0 is 6. So I'm going to point at 6, 0, and -3. We know they have to go up. If it occurs an even time, it bounces. So it's even here, so it's going to bounce at 0, but it's odd here, so it's going to go through. So when I draw my graph, it's going to go through, bounce, and go through. Pretend that went through the dot. Okay, let's factor. Now on all of these problems, I'm going to erase this real fast. On all of these problems, the very first thing that you need to look for is a greatest common factor. Because if you skip that step, it's going to mess you up down the road most likely. So in number 1, we're looking for a greatest common factor, but it doesn't have it. So once I've eliminated that step, now I can pick which pattern is it. So on number 1, I need to ask if it's a binomial or a trinomial. This one is a binomial. So now I need to decide if it's squares or cubes. This one is cubes because the exponents are all divisible by 3s. If it was squares, the exponents can only be divisible by 2. All right, so because it's cubes, we're going to go straight to our first parentheses. The cube root of x cubed is x. First sign matches. The cube root of 27 is 3, and the cube root of y cubed is y. With cubes, the two parentheses are not a match. You do the cube root for the first parentheses, and then the second parentheses, we square the x, change the sign, multiply the two things together. The last sign is positive, and then we square 3y, and we get 9y. Number 2, we want to factor that. First thing we look for is the greatest common factor. We don't have one. We have to ask if it's a binomial or a trinomial. It's a trinomial. The leading coefficient is 1, so I'm going to go straight to my two parentheses, and I have an x and an x. But an x and an x multiplies back to x squared, and we need to multiply it back to x to the 6. So I'm going to have x cubed and x cubed. And now I need two numbers that multiply to -55 and add to -6. Well, that's going to be 11 and 5, and because it adds to a negative, the bigger one needs to be negative. Now over here, after we factored it, our exponents were not an invisible 1, and this time they were 3. So it could, has the potential to work for the cube pattern. With the cube pattern, it doesn't matter if it's plus or minus, but if I look at 11 and 5, I can't take the cube root of either one of those, so I know I'm going to have to stop. Number 3, there's no greatest common factor, so now we need to see if it's a binomial or trinomial. It's a trinomial. The leading coefficient is 1, so I'm going to go straight to my 2 parentheses. I have an x and an x, but that multiplies to x squared, and I need x to the 4th. So I'm going to have x2 and x2. Okay, now we want to find two numbers that multiply to negative 36 and add to negative 5. Well, that would be 9 and 4. And because it adds to a negative, then the bigger one has to be negative, and we get this. All right. Now, because the exponent was something other than an invisible 1, we have to see if it factors further. These work for squares. Squares only work if it's a minus. So right away, we eliminate the plus 1. So now we'll look at the x squared minus 9. Can I take the square root of 9? Absolutely. So when this one factors, square root of x squared is x, square root of 9 is 3, 1's plus, 1's minus. Because when we have squares, the parentheses are going to match, except the signs will be different. But x squared plus 4 could not factor further because it's got the plus, and squares only works with a difference. Cube works with both. Okay, number 4, we're going to look for a greatest common factor. They have x's and y's, so the variables don't match, but I can take a number out. And the number I can take out would be 4. So I'm going to take out a 4, and then I'm left with x to the 6th minus 8y to the 9th. Okay, so greatest common factor is one thing. Complete that step. Then look in the parentheses and make a decision. Don't make a decision until after you've taken out the greatest common factor. So in the parentheses, I have a binomial. For a binomial, we can do squares or cubes. Squares, all the exponents are divisible by 2. Cubes, all the exponents are divisible by 3. Now 6 works for both, but 9 only works for cubes, so it's going to be a cube pattern. So my 4 comes straight down because I always write the greatest common factor. The cube root of x to the 6th is x squared because I'm dividing my exponent by 3. The first sign matches. The cube root of 8 is 2. The cube root of 9 is 3 because I do 9 divided by 3, which is 3. Okay. In the square root, which we just did over here, with squares, that one the parentheses match. This is cubes. Parentheses don't match. I'm going to square x squared, which gives me x to the 4th. Change the sign. Multiply the two things together, writing your letters in alphabetical order. The last sign is always plus. Square 2y cubed. Well, 2 squared is 4, and y cubed squared, you do 3 times 2, which gives you 6. Okay, number 5. First, we're going to look for greatest common factor. Unfortunately, there's not one. It's a trinomial. So we're going to go to my 2 parentheses, and I'm going to have an x and an x. But x and x multiplies to x squared, and I need 6. So 6 could be 1 and 6, or it can be 2 and 3. It's most likely, it's not guaranteed, going to be 2 and 3. Okay, let's see what multiplies to 14. Okay, well, what multiplies to 14 would be 2 and 7, right? So if I try this, this gives me 6, and this gives me 14. They're going to be opposite signs. When I subtract, I'm going to get 8. That's not going to work. So let's see if we can try something else. What if I did 7 and 2? This gives me 21. This gives me 4. Okay, so if I subtract those, I will get 17. And I need the bigger one to be negative. So I need this one to be negative and that one to be positive. And that gives me my negative 17x. And if I look here, the exponent is an invisible 1. Which means it can't factor further, which means this has to be my final answer. Okay, number 6. First, we look for a greatest common factor. It doesn't have one. Then we have to decide if it's a binomial or a trinomial. It's a binomial. For binomials, we have to decide squares or cubes. This one I'm picking squares because the exponents are divisible by 2. So in the square root pattern, the difference of squares, it has to be a difference, which we've got. but the parentheses are going to match except for the sign. So the square root of 81x to the fourth would be 9x squared. The square root of 1 is 1. 1's a plus, 1's a minus. But now I'm going to look at my exponents. My exponents are something other than invisible 1. So I have to look to see if it factors further. They're binomials. The exponent's 2, so square's my only option. But squares only work with a minus. So the first one, I can't factor further. But the second one, I can take the square root of 9x squared, and I can take the square root of 1. So that will factor further. So square root of 9x squared is 3x. The square root of 1 is 1. And when it squares, the parentheses match except for the sign. So this got factored down to this and this. All right. There's the review for your test. Hopefully with this and the review worksheet, which you can check the answer in Google Classroom, that should help get you prepared.